In this video, we'll talk about symmetry. So I want to get started with this with an example. So let's say that we want to reflect the point 5, 2 through the following axes, line, or point. So in A, we'll reflect it across the x-axis, and then we'll do it across the y-axis, then the line y equals x, and then finally reflect it through 0, 0, the origin. So let's draw some axes. And then we can plot this point, 5, 2. So that would be somewhere over here. The x and the y values are both positive, 5, 2. And then in part A, it says to reflect this thing across the x-axis. So that means we draw the mirror image of this point across the x-axis. That would be somewhere down here. So that point is going to be 5, and the y-coordinate becomes -2. So this is across the x-axis. That's the answer to part A. In B, we want to reflect this thing across the y-axis. So we're going to draw the mirror image of this point across the y-axis. So that would be somewhere over here. So this time the x-coordinate changes sign. I'll get -5, 2, and that is across the y-axis. And then C asks for the reflection across the line y equals x. So if I draw y equals x, that's the line with the slope of 1 that goes through the origin. So y equals x. Alrighty, so if I reflect it across that line, I draw the mirror image of my point across that line. That would be somewhere over here. And if I reflect it across that line, the x and the y coordinates get swapped, and I'll get 2, 5. So this is across the line y equals x. And then finally in part D, it says now reflect it through 0, 0, the origin. So let's draw the mirror image of our point through the origin. So through the origin, I get to the origin, and then the mirror image across the origin down here. Now I switch the x and the y coordinate signs. I get -5, -2. And that is across the origin. Okay, and those are all of my reflections. So the next thing I want to talk about is, what does it mean for a graph to be symmetric about a certain axis or line? Okay, so we will talk about 3 types of symmetries. So what does it mean for a graph to be symmetric about the x-axis, then about the y-axis, and then about the origin? So a graph is symmetric about the x-axis if changing y to -y, that's what fills in the blank, keeps the equation the same. So a picture of this would be, if I draw some axes, so symmetric about the x-axis would look something like, the graph has to be the mirror image of itself across the x-axis. So whatever it looks like on one side of the x-axis, it's got to be the mirror image of that on the other side. So maybe something like this. This would be symmetric about the x-axis. And notice that if I look at one point over here on this side, on one side of the x-axis, and I look at the mirror image point of that across the x-axis, those 2 points have opposite y coordinates, and that matches up with what we were saying about this changing thing. We said changing y to -y keeps the equation the same. Even if I change the y coordinate to -y, it'll still satisfy the equation. Okay, next let's do across the y-axis. So for this one, let me draw a picture first. I'm going to draw some axes. So now, whatever the graph looks like on one side of the y-axis, it's got to be the mirror image of that on the other side of the y-axis. So something like this. And in this picture, if I look at one point, and then it's a mirror image, those 2 points have opposite x coordinates. So this time, the way we'll test for the symmetry is if we change the x coordinate to -x, that still needs to satisfy the equation. It's still got to keep the equation the same. Okay, so finally, symmetry about the origin. So let's draw a graph. And for it to be symmetric about the origin, it turns out the graph has to go through the origin. And then whatever it looks like on one side of the origin, it's going to be the mirror image of that through the origin. So the mirror image would be something like this, through the origin. Okay, so to test for symmetry through the origin, now, if I look at 2 mirror image points, like a point here and a point there, both of those coordinates signs got to change. So now if changing x to -x and changing y and changing y to negative y, that will need to keep the equation the same. All right, so let's do an example where we test for these types of symmetries. Okay, so part A, let's test the equation y equals x squared to see if it's symmetric about the x-axis, the y-axis, and the origin. So we'll do it about the x-axis, the y-axis, and the origin. Okay, so for the x-axis, our test is we change the y coordinate to negative y. So that'll give me the equation negative y equals x squared. And then we ask ourselves, well, is that the same as the equation that I started with? And no, it's different because one of the sides has a negative sign. So this is different than what I started with. So my graph is not going to be symmetric about the x-axis. Okay, and I can actually confirm that if I graph it. I know the graph of y equals x squared. This is a parabola, it looks like this. And that's definitely not symmetric about the x-axis. It's not the mirror image of itself across the x-axis. Okay, let's test for the y-axis. For the y-axis, I'm going to have to change x to negative x. So that'll give me y equals negative x being squared. But when I square a negative, it becomes a positive. So I just end up with y equals x squared. And that is the same. I'll put a check mark. So I'm going to highlight this. It is symmetric about the y-axis, and I'll box it. And I can see that visually from the graph. This is a mirror image of itself about the y-axis. It has that symmetry. Okay, then finally, let's do through the origin. So for this one, I change the y to a negative y, and I change the x to a negative x. Simplifying this, I get negative y equals x squared for the same reason, because when I square that negative, it goes away, it becomes a positive. But this is now different than the equation that I started with. It is different, so my graph is not symmetric about the origin. And that makes sense based on my picture. This doesn't look like it's symmetric about the origin. Okay, let's do another one. Let's test y equals absolute value of x. Okay, so y equals absolute value of x. So let's test it about the x-axis, the y-axis, x-axis, y-axis, and then we'll do origin. So for x-axis, I change the y to a negative y. Okay, negative y equals absolute value of x. And that's different. That is different. So it's not symmetric by the x-axis. For the y-axis, I change the x to a negative x. That gives me y equals absolute value of negative x. But when I take the absolute value of negative x, that's the same thing as just y equals absolute value of x. Okay, because when I take the absolute value of the negative, that goes away. It becomes positive. So I just get y equals absolute value of x. And that's the same as what I started with. So this is symmetric about the y-axis. Okay, so it is symmetric about the y-axis. Now for the origin, I change both of their signs. I'll get negative y equals absolute value of negative x. And simplifying, we get negative y equals, the thing on the right-hand side just becomes absolute value of x. And that's different than what I started with. So my graph is not symmetric about the origin. And I could check this with my graph. If I remember the graph of absolute value of x, that one looks like sort of a V shape like this. And that's definitely symmetric about the y-axis, but not about the x-axis or the origin. Okay, let's do two more of these. Next one is y equals x cubed. So we'll test about the x-axis, the y-axis, and the origin. So for the x-axis, I change the y to negative y. I'll get negative y equals x to the third. But that's different than what I started with. So it's not symmetric about the x-axis. For y-axis, I change x to negative x. I'll get y equals negative x being cubed. So then I gotta cube negative x. When I cube this, I'll end up cubing that negative. So that's like negative 1 being cubed. Whoops, negative 1 being cubed. But that's just negative 1. So I'll still have a negative. And then when I cube the x, I'll get x to the third. So I get y equals negative and then x to the third like this. That's also different than what I started with. So it's not symmetric by the y-axis. For the origin, I change both of their signs. So I'll get negative y equals, parentheses, negative x being cubed. Simplifying this one, I get negative y equals the right-hand side we just did. It's going to be negative and then x to the third. And now I can divide both sides by -1, and it'll cancel those negatives away. I'll get y equals x to the third. That is the same. So this one is symmetric about the origin. And if we remember our graph of y equals x cubed, the graph of x cubed looks like, it kind of snakes up like this. And that graph is symmetric about the origin. It matches up with what we got algebraically. All right, let's look at one final example. X equals y squared. So to test for symmetry about the x-axis, I change the y to a negative y. I'll get x equals parentheses negative y being squared. But when I square that negative, it becomes positive. So I'll get x equals just y squared. So that's the same as what I started with. So I do have symmetry about the x-axis. I'm going to box this. For the y-axis, I change the x to a negative x. I'll get negative x equals y squared. And that's definitely different than what I started with. Definitely different. So it's not symmetric about the y-axis. For the origin, I change both of the signs. So I'll get negative x equals, in parentheses now, negative y being squared. So this is negative x equals, but I know negative y squared. We did it over here. Negative y, when I square that, is just y squared. That negative goes away when I square it. And this equation is also different than what I started with. So it's not symmetric about the origin. This one is just symmetric about the x-axis. And if I were to confirm this with the graph of x equals y squared is actually a sideways parabola. It looks like this. And that graph is symmetric about the x-axis, but not the y-axis or the origin.